Okay, Dylan. So as we're talking about permanently stabilizing your walls, a lot of our homeowners really appreciate understanding what caused these problems and how they came into the situation to begin with. So right here, I have a few short slides I'm going to share with you, just to give you a better understanding and maybe a better visual as to why you might be experiencing wall failure to begin with. Okay?
Perfect.
So when your home was originally constructed, essentially they had to dig out an excavation site for them to properly build that foundation. Now your foundation is comprised of three main parts. You have your footing, your concrete floor, and your foundation wall. Now there are two types of foundation walls, typically. In this instance, you have a block foundation wall, okay? And so after the foundation is complete, contractors then backfill with soil to fill all those remaining voids that they originally had to excavate out. Now this is going to lead to something that we call loose backfill soil, okay? Now the main soil type I want you to focus on here is actually going to be this compacted virgin soil. Okay, the reason that this is important to us is because compacted virgin soil has been naturally compacted over time through hundreds, if not thousands of years. So essentially it's really stable and it's never moved.
Wow. Hasn't been touched.
So the reason that loose backfill soil is a problem for us is it creates something that's called an active wedge. And what this is going to do is it's going to cause a lot of lateral pressure onto your walls, causing them to fail. Essentially that soil weighs thousands of pounds. With me so far?
I am.
Perfect. And so being that we live here in Seattle, what do we get a lot of?
Heavy rainpour.
Exactly. And when we get that heavy rainpour, that water is going to follow the path of least resistance, and it's going to trickle down through that loose backfill soil and create something that we call hydrostatic pressure. Okay, and to put in perspective, water weighs anywhere from 8 to 9 pounds per gallon, so it's adding more weight to the problem.
I get that.
And then in the winter, what happens to that water?
Freezes.
It freezes, right? And when water freezes, it actually expands about at 9%, okay? So with the freezing of the water, the hydrostatic pressure, and that loosely backfilled soil, it's creating a lot of lateral pressure on your walls, causing them to fail. Is that making sense so far?
I'm gathering, yeah.
Perfect. And so pretty much there are four main stages that attribute to wall failure, being that you have a block foundation wall, okay? The first stage is going to be a horizontal crack, okay? It's this horizontal crack that you see along your foundation wall, knowing that you've reached stage 1.
All right.
Stage 2 is something that we call stair-step cracks. Now you can kind of see by the visual here as to why they're called stair-step cracks, right? Because they look like stairs, okay? The third stage is going to be something that we call tipping and or shearing. And what that is, it's where the top of the wall starts to tip inwards or the bottom of the wall starts to bow inwards, okay? And then what do you think the last stage of wall failure might be?
I'm scared to say it, but failure?
It's going to be total wall failure, right? Okay, so
Oh my goodness.
based upon this information, where do you feel like you're at with your wall?
I feel like I'm in stage 3.
I'm in stage 3, yes. So being that stage 4 is wall failure, can we both agree that this isn't an option for us and we need to permanently address this issue?
Absolutely.
All right, so this is out of the picture.
Totally.
Okay. So historically, there have been a few main options that homeowners or contractors have attempted to do in the past to help repair this type of situation, okay? The first one is something that we already hit on, but it's do nothing, okay? And what do you think is going to happen if we just do nothing?
Stage 4.
Stage 4, complete wall failure, right? So if you were walking along the sidewalk and you tripped and fell and you broke your elbow or wrist, would you go to the doctor or would you do nothing?
That's an obvious one. I would go to the doctor.
Go to the doctor. So can we both agree that doing nothing is not an option?
100%.
Okay. Next is something that we call do-it-yourself or DIY. Now look, I know in today's age, YouTube University has a wealth of knowledge, right? Okay. However, most homeowner circumstances, they don't have the proper expertise, the access to the proper materials, or the proper equipment to perform a procedure like this. All right?
All right.
All right. And lastly is something called foundation replacement. Okay, the problem with foundation replacement is that it's expensive, invasive, and all around time consuming too. What contractors are having to do is excavate around the entire perimeter of your home to access that foundation, to rip it out and replace it with a new one. So what they're going to do is they're going to crib up your home and put it on stilts, and contractors don't like the liability of having the homeowner in the house while this project is going on. So that means you're having to be out of your home for 2 to 3 months.
I mean, that's...
Does that sound like something you want to
I
do?
mean, it's not an option for my wife and I.
Okay. As I mentioned too, excavation is required, so it's really invasive. So anything that might be in the way to get access to that foundation, like HVAC, gas lines, sewer lines, that brand new patio that you just put in the backyard, that all has to be ripped out. Does that sound like something you want to do?
It's not a solution.
Solution. And once again, total foundation replacement doesn't address the underlying issue here, which is the soil conditions. So imagine ripping out all that old foundation and replacing it with new foundation. You're not really fixing the problem here, right?
And spending all that money to have it not be fixed, it's not, that door's closed.
Okay. So based upon these historical options for repair, can we both agree that doing nothing isn't an option and that we permanently need to address this issue?
Absolutely.
Okay, and we can see why none of these options work, right?
Absolutely.
All right.
It's not an option.
So that's where we come in. Groundworks, we create something called the settle stop wall anchor system.
Okay.
Okay, and now I have a short video clip here that our engineering department put together that explains this at a really high level.
All right, let me look at that.
We're going to play this for you, and we'll take a deeper dive as to what this means, okay?
Thanks.
Okay. So, to kind of sum up in that video, here's a little visual representation of what the system looks like, okay? So here's that earth anchor plate. There's that galvanized rod that he was talking about, and this is the plate that gets installed on the interior of your basement wall, all right?
Mm-hmm.
So the installation process is super simple and straightforward. We're going to use engineered spacing to determine the location of the anchors. It's typically 2 feet from the corners and then 5 feet after that until we reach the other corner. We have to permanently stabilize that entire wall, okay?
I'm getting that, yeah.
Okay. From there, we're going to drill holes in the foundation wall to insert those rods. And the great thing, after we drill those holes, we're also going to fill it with a wax seal too, so that no water from that hydrostatic pressure, as I mentioned, can seep into your basement.
That's exactly what I'm looking for.
Okay. Then a trench is excavated on the exterior of that foundation wall, about 8 to 12 feet from the 8 to 12 feet from the perimeter, and then we're going to insert those rods at about a 10-degree angle. Now we insert them at a 10-degree angle because our goal is to reach that active, or not active soil zone. That goal is to reach the native soil that I mentioned before. That is
virgin soil.
The virgin soil that is really compacted and really stable.
Okay.
Okay. And then from there, we're going to attach the earth anchor plate from that site that we originally had to excavate. All right. And then we're going to install the wall plate on the interior of the wall that I showed you. And then we're going to torque it down to the engineered specifications. And to kind of give a better visual representation, kind of think of like a vise. As you turn the vise, it comes closer and closer and closer together. That's essentially how this system is working here.
So it's pulling from the compacted soil to my wall and it's making it stable.
Yes. Okay.
Okay.
Now our main goal here is to permanently stabilize your wall.
Yeah.
Right? We will do everything in our power to attempt to get that wall back to its original position.
Okay.
However, it isn't a guarantee. As I mentioned, our main goal is to permanently stabilize it. I just want to make that clear.
That's all I'm looking for.
Okay. And then afterwards, after it's installed, we're going to put the soil back and compact it to the degree that it needs to be. And it pretty much looks like we were never there. All right. Here's a little bit of our product certification about this system. Okay. It pretty much goes through a PEI evaluation service. Just a fancy way of saying that engineers have overlooked this system to ensure its structural stability and that it's going to permanently address the issue that we addressed.
All right, I'll look that over with me and my wife, but this sounds like a perfect solution for me.
Awesome, man. So, based upon this information that I just shared with you, do you feel like this is going to be a permanent solution for you?
Absolutely.
Awesome. And the great thing about this is it comes with a fully transferable structural warranty.
How long is it?
It's for a lifetime.
What?
Mm-hmm. So it's not tied to you as the homeowner, it's tied to us as the company and to the home.
So if it fails, I can just call you and somebody will come out?
Yeah, so we actually also offer an annual service too. So annually, a service technician will come out to continue to torque those anchors down in hopes or attempts to get that wall back to its original position. But
All right.
I just want to preface again, our main goal is to stabilize the wall, okay?
Absolutely.
Okay, over time, hopefully that wall will return to its original position. We will attempt to do everything we can to get it back there. However, it's not guaranteed, all right?
That makes
We're
sense.
just looking to stabilize it.
That makes sense to me.
Okay. However, if you do want the ability to straighten it out upon installation, we can. However, we're gonna have to dig out the backfill soil that's behind or on the exterior of that foundation wall, and then we're gonna have to push up your floor framing system just for a little bit, so then that way there's no more lateral pressure bearing on those walls, so we can easily get them back to its original position.
That makes
Okay,
sense.
so this can be an option if you do want to get back to its original position right away. However, as I mentioned with our annual service, a service technician will come out annually and torque it down to the specifications that it needs to be. And over time, our goal, or hopefully, that wall will return to its original position.
Connor, I appreciate you.
All right. So, just once again, based upon that information, do you feel like this is going to be a permanent solution for you and give you the results that you're looking for?
This is a solution for me and my family, absolutely.
Awesome, man. We'll go ahead and add a few of these to the cart and I'll get started on your proposal, okay?
Thank you, sir.
You're welcome.